Right, ladies and gentlemen, you must please try to be on time. Okay, so we ended up on this place. Run. Okay. Right. So we ended up on Friday. We ended up on Friday with some vague feelings about not being comfortable about scope. So to understand the memory management in object orientation, you need to understand it in the non-object environment. Right, so I sent you these 2 pages from a previous 114 test. So let's just control what you have to know about the scope in the static environment, in the non-object oriented. My yellow key. So, this is a module, right? Public class scope from the test of May 2014, right? This is my module. Notice the blocks around the module, yes? Every method, every static method has a module gets a block of memory. Why? Who gives it to that module? You know that you write a Java program. Right? Text, human readable. My.java. Yes, it's a text file, it's an ASCII file, it's human readable. That's what you type in the editor. Say Java C Java. What does that do? Well, Java C is a program called a compiler. Into binary code that is executable. Right? That's all it does. It creates a file and executable code. Then you say Java my. Yes. What happens then is the question. Java is, that is a program. The base, that is a program. That is a program, and it will take your binary file and execute that binary file. How can a program execute another file? It cannot. The CPU executes. So what happens is that this environment, if you want, the runtime environment, communicates with the operating system. And it asks the operating system, where can I load this executable code into memory? It asks the operating system to execute code. Yes? And it communicates with the operating system about memory management.
So Java is the program that communicates with memory management.
Let's call it the environment, yes. Read, if you're interested in that, read up about the Java virtual machine. Yes. You don't need, but you need to know who is doing what. I cannot keep on saying the computer is. So I just want to get that pipeline right. From the text, you run a program called a compiler, which creates a class file, which is the binary code. Yes. And that, when you type Java, you starting the Java virtual machine, which communicates with the operating system about running your program. And that includes not only executing, but also doing memory management. Okay? Demystifying things somewhat. Okay. So now I'm going to say the computer. But I say the computer, communication between the Java virtual machine and the operating system. Right. So, scope. This has got nothing to do with object orientation. How do I know that? Because it is static. Yes. So this is a plain forward, straightforward module. Let's look at memory management. The moment I compile this thing, I get an executable file, binary file, called scope May 2014. And when I run this, this is placed inside memory. The executable code is placed inside memory. So the code gets into memory and the data gets memory. Yes, so there are two things in memory, the executable code and the data. Incidentally, as far as security is concerned, hacking, if you can get a computer to execute data, it's wonderful. So the operating system doesn't stop you because it thinks it's data, but actually you're putting executable code into data, which is not transparent, it's just data. Okay, cool. That's how viruses and worms and things work. Very often, not the only way, but very often. Okay, so I have my program code and I have my variables in memory. The moment I I can divide the memory for the variables into the memory. That's my big block on the outside. And I can declare a global variable. This global variable is visible throughout the scope of the whole class. Yeah, we'll come back to this. Normally, when a Java program executes, the first thing that executes is main. So whenever a method starts executing, it will be allocated for all the variables declared in that method. Yes? There it is. When another method is called, the execution environment for that method is loaded. It's on a stack. It's literally on a stack, right? So here I have main in memory and its associated variables. F. Code forwarded with the space for its variables. When I exit F, yes, either with the return or the last curly bracket, this disappears from memory. Right? Okay. And so on and so on. Here I have main calling F. I go to F. F calls, F calls H. So another method is loaded there. Yes. And it's associated memory, and it executes, it returns, this memory disappears, I come back here to after H. When this whole thing is finished, that memory disappears and I come back into main. I assume you're familiar with that? Yes or no? Yes. Or undecided. Okay. Now, what happens to the memory? So main gets its own little memory. There are all the variables. I get this memory. I have x, which is the primitive type, n is primitive, int y. Now this is a reference variable, as you so well know, because this is an array. So I get a y there, and then, okay, this is a shorthand. If you knew, not KNEW, but NEW, when it's initialized, the values are written somewhere else in memory, and there will be a reference to that memory address. When I call f with x and y, what happens with primitive parameters? What happens with primitives? The value of x, because x is a primitive type, the value of x is copied to the corresponding parameter there. Okay? The value of y will not be copied because this is a reference type. So the reference is copied, not the values, just the reference. Are you all with me? Who's lost? No, cool. Right, okay. If I am here and I make a change to C, then I get to this reference, I see it's a reference, I come back here, I see it's a reference, and I change the values here. Right? Because this is a reference parameter, the original values are changed. If it is a local variable, like here, which is a primitive type, the value is changed here, but the value of x over here does not change. Even if I say x becomes 4, that value becomes 4, but this one stays 99. Yes? Because this is a pass by value, not pass by reference. Okay? So when this thing finishes, this memory disappears, but this method has a side effect because it has reference parameters. So those changes will be visible here in main. Okay? Are you all happy about that? Okay? Right, so kom julle Vrydag nog sien. So, right, so objects. Objects are references. So I cannot pass an object by value. I'm passing a reference. Yes. So when you work with an object, you have to that you are working by. You need to write out the memory for various examples. Specifically, look at all the previous tests that are available on SunLearn. Work through those. You know that question 1 in the test of the 11th of August, 11th of August, Thursday. The first question is definitions. The question is draw the memory. Okay, I will give a template for the test, which says what each question will be about. Then you know how to prepare. And actually you feel as if I'm being nice, but actually I'm just forcing you to learn the things I want you to learn. So we're all happy. Okay, question 2 is draw the memory. And I will do like this. I will give you, for example, an array of objects. I will call an instance method, change things, go around, then ask, draw the memory, draw the memory, draw the memory. Right? So if you know how references work, then it's cool. Remember with the assignments, when you get to an assignment, if you think like this, you are not copying values, you are copying references. Okay? So if you overwrite the previous, you're frowning. Are you concentrating or are you lost? You cool? Yeah. Actually, the person next to you, but so be it. Okay. So what can happen is look at color. I declare a color that gives me a name in memory, and then I knew it, I get the reference values are filled in. Okay? I do the same for B. And then I say, put the value of A in B. And that's simply copying the references. Because A is a reference, B is a reference. If I want to get to the values, I must make sure that I follow the reference by set or whatever the instance method is, okay, to get to the values. Just working with the names does not give me the value, it simply gives me the reference. Okay. But this means, look what happened here. Since B and A as references now have the same values, this thing that was originally created there by color B equals real color, blah, 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 I cannot access these values anymore because I lost the reference. Yes, I overwrote the reference with a new value. Therefore, this is known as an orphaned object. I cannot get that. So, memory management. What happens with these poor weeskindertjies? Those poor orphaned objects. The Java version does automatic garbage collection. What does that mean? Remember, the Java virtual machine communicates with the operating system and requests free memory from the operating system. It can also tell the operating system that some memory is not used anymore and may be reused for something else. Okay? So what the Java virtual machine does is periodically, while your program is running, it will check whether memory has been allocated as in use by your program, but there are no references to that memory. If so, it will place a call to the operating system telling it that this block is memory is now again free and may be reused. Now that means that there's extra overhead to your program, right? So your program will take a longer time to run because the Java virtual machine will periodically just check for you if your memory management is okay. The true hackers hate that. Yeah, the true hackers don't like that kind of thing. So in a language like C, the programmer has full control over memory allocation. Yes, give me a new block of memory, and freeing up memory that is not used anymore. which means that if the programmer has an itsy-bitsy tiny little weeny bug somewhere, that it is possible that your program, you as programmer, has a program that reads invalid memory. Because let's have a quick look abstractly. The operating system allocates memory. When a process or a program, when a program runs, that program, I'm going to call it a process because that is operating system terminology. That process can request memory, and memory is allocated for that process to use. So the operating system has a list of processes that are running. You know that a computer can run a lot of things simultaneously, yes? I can have my browser open and compile and run and edit and whatever all simultaneously. No, it doesn't happen simultaneously. The system keeps a list of processes that want CPU time, and then it sets through them. This one gets a bit, that one gets a bit, and so on and so forth. But it happens so quickly that it seems to you as if it's simultaneous. Okay? One at a time, one CPU, one process. And incidentally, these fancy CPUs with their 7 cores, if the software doesn't support multiple core execution, it still runs in the list. Okay, so don't be too impressed by that. So it's run 6 block of memory. Okay. The operating system has what we call a pool, which you can think of as a list of available memory positions. So when the Java virtual machine requests a block of 4 integers, for example, from the operating system goes look in the pool and say, are there 4 adjacent integer? Is there a block of memory big enough to fit in 4 integers next to each other? Oh, yes, there is. Cool. I give you the reference to that little block, and I mark that block as being in use. Okay. Now, when another process or my own process requests more memory, it cannot use that memory. That memory has been flagged as in use by the operating system. If you, in C, allocate memory, but you forget to free it again, that means you can use memory, and it never gets freed, and your process runs out of memory. Okay? That's known as a memory leak. If you free the memory in C, yes, not in Java, because Java does it automatically. If you as a programmer freeze the memory, you might make a itsy-bitsy mistake and accidentally free the memory from, instead of freeing 655, 656, and 657, you free those 3 blocks. Yes? Okay. When you free memory, the memory is never cleared by the operating system. So even though this block might be free, it will still contain the values that are there. Yes? Which means that if I free something and then accidentally start using it again, then I'll see my old values. So my program will look as if it's running correctly. But then somewhere along the line, and this seemingly happens randomly, somewhere along the line, your program allocates another batch of memory, and then sometimes it will and sometimes it won't overlap with the block of memory over here. And then you override that. And then it seems that you get strange values which you never put into a variable, but that is because free memory was still referenced, and sometimes it's overwritten and sometimes it's not, and it's absolutely dependent on circumstances. Okay, so then you get these random errors. So there is a huge debate about whether the programmer should have control over allocation and freeing of memory, because that gives you total control. We all like that. Pinky in the brain, yes? Total control. On the other hand, to lessen the possibility of bugs, of wrong programs, we can have automatic garbage collection. What is the disadvantage of automatic garbage collection? Well, it makes your code easier to write and understand, but it will make your program somewhat slower. Okay? Sometimes it doesn't really matter if you have a bug in a program. However, if your code is flying my Dreamliner airplane, or if your code is running a nuclear reactor or my heart-lung machine in hospital, it has got to be, you've got to be bloody sure it's always correct. So there are safety critical programs, which has to be correct. And then there are other programs where it's just inconvenient if it's not quite correct. Okay? So these 5 pages about memory management, orphaned objects, allocating the memory, is 20% in your test of the 11th of August. You've got to understand this. Okay? You cannot test it on, well, you could. You know that you can write memory addresses, yes, in hexadecimal. So you could try that. Otherwise, work through the old tests, and most of the memos are on the web as well, and see whether you understand it correctly. Okay? That is it. So that completes using object orientation. So that is the end of section 3.1. Are there any specific questions? You all happy? Cool. Oh, what do I expect you to know about section 3.1 in the test? You have to read the book. Work through the questions and answers at the end of the section for your own enjoyment. Work through a few of the creative exercises. Sorry, not the creative. For your enjoyment, the creative exercises, of course. But then also look at some of these questions in the exercises. Okay. But you definitely, we did every single line in the book. Yes. And when I set a test, I read the page, I think, is there a question here? Oh, goody, there's a question. Let's take that one. And I'll take this statement and put a question mark at the end. It makes it easier for me to set the test. I hate tests, but anyway, okay. Work through the previous year's tests. If you can manage the tests of the last 5 years, you will pass one. Work through them. It's why they are there. And it covers every single line in the book anyway. Right. So now, what do we know now? Up to this stage, we looked at what is an object, how is the memory managed, given an API for an object, how do I call it? How do I run my client code? That's cool, but you're computer science students, so what you want to know is, I want to make my own objects. How do I create an object? And that is section 3.2, where we look in more detail at how do you run that code. In 3.1, you just got the API. Now we're going to look at the code itself. How do I implement an object? Okay? So we're going back to the silly little, I don't like charge. But anyway, okay, there it is. It's in the book. So this is what we saw in section 3.1. And we didn't ask anything about it. What we want to know now, how do I make a constructor? What does the Java look like inside charge.java? How do I make an instance method? How do I write this thing? Okay. And it is not very difficult. You write straight Java code, but with a few exceptions. Inside my Java code, remember we talked about instance variables. So if I have this class, public class charge, if I declare a variable inside here, that thing is known as an instance variable. But there are certain modifiers, and by modifiers, I mean the access control to a variable. Up to now, the only access control we had up to now was manipulating the scope. Because what we had was, if I call a method, I either have a global variable, which is visible in all the methods, or I have a local variable, which is just visible there. Right? That was the only access control. Who can see which methods can see which variables? That is what I mean by access to a variable. So now we are making objects, and we want our client code to be able to use the objects. But in making these objects, we will declare variables that are inside the objects, instance variables, that I just use for calculation purposes. So if I have a variable I which simply controls my while loop, for heaven's sake, my client doesn't need to be able to access that I. Yes, it's a temporary variable, it's a local variable that is just used for calculation inside the object. Right? So some instance variables, yes, can be modified to say that that instance variable is private. A private variable means it's not visible from the outside. So if a variable is private, it's not visible from the outside, so my client code would never be able to talk about Rx, Ry, or Q. Yes? So private is the first modifier. The opposite of private is public. Final means that that variable is a constant. Its value can never be changed. So if a variable is final, it means the value cannot be changed. Okay. Right. In the same way, final means a variable gets an initial value, and that initial value can never be changed. right? Because somewhere along the line, it's got to get a value once, and then it cannot be treated. Right, so this is an idea here. These are the instance variables Rx, Ry, and Q, which are private and final. So my client code doesn't know about these. I can give values, and then I may never use Rx, Ry, or Q in an assignment again. Okay, because they're final. Right. The same thing happens with the methods. Now, charge over here is my constructor. So I make it public. It means that my client code can call that method. But again, just like some variables may just be local calculations in an object, some instance variables, I can also have some methods which are just for that module, just used for calculation. Yes? And those, if I declare them private, it means it's not part of the API, so the client cannot call them. Okay? Otherwise, they're public. So, how do I write a constructor? Basically, what I do when I write a constructor is I initialize my instance of the object. Yes? So I will have private final variables, and I will give them their initial values. And that is all that a constructor does. And remember, when we talked about using an object, we said the constructor creates an instance and initializes the values. So when you write the Java, that is exactly what you do. Okay. Instance methods, it may or may not return a value. I can have a public or a private instance method. Aha, I can have a local variable, which means that this instance method will be called, it will get a piece of memory with these values. The moment I return, this memory will disappear. Just as in the static case. Right? And Bob's your uncle. This potential address calculates something. Note that I cannot use Rx and Ry and Q as receiving values. I can use their values to calculate new values, but I cannot change the value of Rx or Y. And this is, of course, a static method. Okay? So this is all very easy. I may give you a Java program. That is question 3. And then yes.
Why did you integrate a
Okay, so that's a very good question. Why do you want to create a variable where you can't change the value? It seems like an oxymoron. Yes, it's variable, but it's fixed. Can't change the value. Charge is a very good example of that, because what this whole class does is a charge object gets initial values, yes, and then you always use those values to calculate the potential at a different place, at a different XY position. So charge is not supposed to change. Let me think of another good example. I can't, not often. Yes, there's another question. Because these are very simple objects. Charge is a very simple object. Think of the a static case, not object-oriented. You don't want a method that is 20 pages long. So what you do is you write a method that calls a few other methods. Other methods do is just the calculations where you need the answer. And sometimes your class, your object, the instance methods for your object has to return an answer, but in order to return that answer, it needs to make a lot of calculations, which you don't want to put into the instance method. So it's basically just the design, making the design cleaner. It gives you also more control over what the programmer or the user, the client, can do with your object. Why did you, from the beginning of the year, why did you use static methods? Because you wanted to organize your code with a certain hierarchy, with a certain structure, right? And what you're doing at the moment is the same thing, but for the data. So you want to, why would I not want anybody to be able to access all variables? For the simple reason, if I then get an error in my program, anything could have caused it. So if I organize my data in a controlled fashion, I know that errors can only occur at specific positions. So I have an object, everything is open. Yes, the client can call anything, anywhere. I get a bug, which we all do. Yes? Then I have to trace the error. But if I know that that error can occur only in my object, in my class, only in the instance methods, I can ignore the client code, which might be millions of lines of code versus the 20 that's my implementation. So it's just easier to find a mistake.
Sorry, this is really on the location. What is the tape folder saving?
Come to me after class because that's off topic. Okay, right? Okay, right. So this is what you do. You have different kinds of variables. So I could give you a Java program and say, please identify all the argument variables, please identify all the local variables, please identify all the instance variables. Incidentally, that's always in CS144, that's my first question of the first test, and they always get it wrong. So that is a possible question for your test. Okay? And here is then the full implementation of charge. Previously, all we could see was the name of the constructor, the fact that there's an instance method potential at, and that there is a method to string. Okay? And now we see what the Java code looks like. I have 2 minutes. Right. Then we get examples. Read through stopwatch. Read through histogram. And there you are. Thank you very much. On Wednesday, sorry, last comment. People keep on mailing me about the wrong information on the website. I don't know where you go to what website. You have to go to SunLearn, you have to go through your list of courses and click on 144, that website is outdated. Any other one that you're accessing is outdated. Okay, see you on Wednesday. Right.